So let's welcome to the solution of day 20 from Advent of Code 2022. So Achim, let's describe your solution, please.
I first start with describing a problem that occurred. So we have to mix around an array of numbers, go through that, and we have to proceed the individual entries in the order that they are presented in the original data set. So we have to move this first, this second, this third, this fourth, and so on. The first problem is we just can't go that we say, okay, we move the item at index 0, then the item at index 1, at index 2, at index 3. That doesn't work because the indices are moving as well around all the time because we are moving stuff around. So when we go through this example description, the first thing we have to move is this 1 from position 0 to 1 because it's plus 1, it moves 1 up. And the second we have to move is the 2, which was at 1, now is at 0. So these items move around all the time. So what I did is I pass my input, each number on a single line, into a list of number entries, and these number entries have the value as presented by the input and a work order number.
Okay, what is work order?
These work orders are the original index, the index from the original list.
Okay.
So the zeros item gets 0, the first item gets 1, 2, 3,
Okay.
4, and so on and so forth. That doesn't change.
To save the origin order, the origin index.
Exactly.
Okay.
And when then sorting around, I iterate through the entire array, each time search for the next item. That is horrendously inefficient.
Okay.
Maybe with a hash map that would be faster.
You search the number in the whole list to get the
Yes.
new... Okay, to get it, okay.
But for the puzzle input, it has 5,000 entries. It's not that expensive.
Okay.
If it would be 2 million, that would be a different thing entirely.
Okay.
But
How do you implement the overflow if you have -3 and you have to left on the left side the array and
Exactly.
What is the magic in your code for this?
we encountered a problem, all three of us, but seemingly I am the one who solved it. So when moving around and moving beyond the left and right bound, start with the right bound because that is easier. We have so get the target position from the current index of the item plus its value. And if that is beyond the right bound, upper bound,
The right bound is the
bound,
deeper if condition.
we need to do a modulus operation,
Yes.
but not against the length of the data set, but the length of the data set -1. I'm not entirely sure where the -1 stems from, but this way it works.
Okay.
And the same goes for any target position crossing over the left bound, the lower bound, so it gets negative. But just doing the modulus will still leave us with a negative value. So we have to add data size minus 1 another time that we get positive. My first attempt at these were 2 while loops, which got me in trouble in the second part where the example took 11 seconds.
Yeah.
And real data would have required something like 2 point something hours. Using modulus, just cut it down to 1 millisecond for part 2 and 0.8 seconds for the real data. Regarding the second part, there comes a crazy elven decryption key, this number, which is applied to any number value provided by the input, by multiplying it.
Yeah.
So the 0 stays 0, but everything else grows a lot bigger. And you have to mix the list a number of 10 times. And it's also important that the work order, that's why I extracted a separate method, stays the same. So take the work order from the
Okay.
and don't change it over.
Understand.
Just stay with it.
Okay. Thank you, Achim. Achim, what was the biggest problem in this riddle? Was it the boundings?
Yes.
Okay. Thank you. Then, goodbye, everybody. We see us tomorrow at 6 o'clock again. Thanks a lot and bye, Achim.
Bye.